Okay, everybody.
I can't hear the audio right now.
Hello. Hello. Hello.
Yes, this is now the audio is back. I think you walked a little bit too far away.
If I can do something about that. All right. Now, can you hear me?
Now we can hear you.
Okay. It's all yours, man.
Oh, okay. I think for the people on the stream, they missed out the introduction. But yeah, I'm good to go. Let's get started. Where is the screen sharing? One second. Okay. Sorry, I had some issues with my laptop, but all good now. I can't hear your audio. Can you still hear me?
I can still hear you. Yep.
Okay, perfect. Then I'll switch over. Cool. Can you see the slide deck as well?
Yes, we can. Perfect.
Cool. Then let's get going. Welcome everyone. I'm Jaap Brasser, and today we're going to be talking about the PowerShell Core, bringing the PowerShell magic to every platform. And to kick it off, I'd like to start with this image. Most of us are probably Microsoft-oriented guys, but nowadays things have changed significantly. Microsoft isn't the Linux bashing party they used to be. We've seen, if you've been coming to conferences, you've been seeing these stickers being handed out. And I even have one of those stickers on my laptop. In case you didn't notice, I'm also doing this presentation from a MacBook, because I figure if I'm going to talk about PowerShell Core, open source, then I might as well eat my own dog food and actually do. So whenever I'll be talking about Windows functionality, I took screenshots of that, so I can still make those comparisons. So a little bit about myself. I'm Jaap Brasser. I'm a PowerShell engineer. I work at Rubrik for a department called Tech Marketing. So marketing still sounds a bit scary to me, because I've actually always been an engineer, and I still am an engineer, but I now work within a marketing department. I do a bit of blogging. I do speaking, like I'm doing to you guys today, and mostly focused on cloud automation, scripting, and security. As for Q&A, I'm not sure if you're still near the microphone, but if at any point anyone has a question, feel free to relay it. I don't mind taking any questions during the session. Cool. The silence, I assume that you're not near the microphone. So for everyone, happy Valentine's Day, because here in Holland it's already the 14th of February. So happy Valentine's Day. What we have for today, we'll talk about the state of PowerShell. So what has been going on in the PowerShell world, where do we come from, and where are we at now? We'll talk about the differences between the PowerShell versions. We'll work a bit with cross-platform code and what kind of considerations we have. And we'll also talk a bit about working with the Azure module and Azure Cloud Shell. I'm not sure how many of you are familiar with Azure Cloud Shell, but we'll give a bit of the basics of that as well, because it's quite cool technology. So what is PowerShell? Well, you guys are a PowerShell user group, so probably don't have to dive too deep. I won't actually read what's on my slide. So PowerShell has been around for some time already. First time I saw it was on Windows XP, when one of my colleagues showed up with this cool automation language, and he showed it to me. And I looked at it and I thought, okay, so I can get my processes and I can select certain processes. But I thought, yeah, I also have Task Manager. So what do we really need this for? Well, that was in 2006, and since then I've taken in the gospel of PowerShell, and right now we are currently at PowerShell version 6.1. It's also no longer called Windows PowerShell nowadays, as it's called just PowerShell or PowerShell Core. So what are the differences between the different versions of PowerShell? So if you're running Windows PowerShell, you have the PowerShell.exe executable. When you're running PowerShell Core, it has been renamed to PWSH. Unfortunately, POSH, so PowerShell in short, was not available. So we've had to get used to this new command name. Main difference from a development point of view is that PowerShell, Windows PowerShell is running on .NET 4.5. If you're running the latest version, which is Windows PowerShell 5.1, and PowerShell Core is running on .NET Core 2.1. The main difference there is that .NET Core is cross-platform, so we can use it on any operating system, and as a result, we can also use PowerShell on any operating system. The PowerShell Core is obviously open source, and we can use it practically anywhere. And when I say practically anywhere, it's not just a selection of Linux distributions, but also on Mac, and there's even a ARM version of PowerShell out there for Raspberry Pi. So today we can use PowerShell wherever we want and however we want. So a bit of the history of PowerShell Core. It was first announced already. Now I have to calculate how many years ago is this? Is this already 1.5 years or 2.5 years? Anyway, in August 2016, it was first announced. Then it took a year and a half until January 2018 before it was generally available and supported. And only 9 months later, last September, we got to PowerShell Core 6.1. And currently, we're working towards the release of PowerShell 6.2. So if you notice the timeline here, this is an old picture. Oh, this isn't good. I'm not sure. Is everything still okay on your end? Let's see. Can you still hear and see me? I switched back to.
Yeah, I can still hear and see you.
Okay, cool. Yeah, I got the spinning Mac wheel of death, so I thought everything just broke. Okay,
Nope,
so what?
Yeah, you're good.
Okay, I'll keep on tracking. So what you can see here, the planned release dates for PowerShell, we can see that PowerShell Core 6.1 didn't quite make it. They're aiming for 6-month release cycles, and this is a big change since Windows PowerShell, because with Windows PowerShell, whenever a new operating version of an operating system came out, we would get a new version of PowerShell, and now it's completely independent from the Windows releases. So features can come out more frequently, and because it's open source, we can also contribute our own features to the PowerShell Core code base. But what this also means is that PowerShell Core has a different support model as compared to Windows PowerShell, because it's only supported for a year. The old version, so currently PowerShell Core 6.0 is only supported for a year after PowerShell Core 6.1 is released. So upgrading is becoming more important, because pretty soon PowerShell 6.0 is already no longer supported. The upside of this story is when we were using Windows PowerShell, whenever we did an upgrade, we needed a reboot, and a lot of system files were changed. With PowerShell Core, the installation of it is as simple as extracting a zip file, and all the components, including the correct version of .NET Core, are available to us. Okay, I'm having some issues with my PowerPoint. Not sure what's going on.
Issues with PowerPoint on Mac, you don't say.
Yeah, who would have expected that? Okay, so PowerShell licensing. So as a result of PowerShell being open source, it's now been licensed under the MIT license, which is also known as the license you can do whatever you want with it with very few restrictions. So you can grab all the source code and make your own version of PowerShell if you want to, or if you want to be part of the PowerShell community, you can take a look at the source code and make improvements. And to give you an example, I'll switch over to my browser. Switch over to here, and I'll open up GitHub, PowerShell. So we'll go into the PowerShell repository, and I'll just give a quick overview of what kind of people are contributing to a PowerShell module. So, oops. So we can see that nowadays it's no longer just the PowerShell team contributing. We see a lot of GitHub handles of other people. So if we take a look at how many times we find thanks on this page, we see that we have so PowerShell has really become more community driven. The way it currently works is that it's mostly Microsoft staff members that are approving the pull request. I think there's one. I forgot his name. I think there's now also one person who left Microsoft, and he's still allowed to approve pull requests. And in the future, as they're opening the repository open more, it's expected that also more community members will be able to help out with that. Cool. So the performance differences. I have a small command here. It's called using the measure commandlet. What we'll do is we'll start a PowerShell job. We'll run get process. We'll wait for the job to complete, and then we'll start over. And we'll do that 5 times just to see what kind of overhead it generates if we use the start job commandlet. You can also see that we'll run this command with start thread job, which is a PowerShell 6 lightweight version of PowerShell jobs. So this one relies on run spaces, and we'll see the performance difference. Since this command is not available on PowerShell 5, what we can see here is that we'll get an error for that one. But just running start job 3 times and waiting for the output to come, we can see that this takes a minute and a half. And now if we switch over to PowerShell 6, and this is PowerShell 6.11, we can see that even if we just run regular start job, we already get a performance improvement for over 50%. But once we switch over to start thread job, we can see that it's only 0.3 seconds. So there's some huge performance differences that you can get immediately by switching over to PowerShell Core. And the advantage of it is that you can run PowerShell Core side by side to Windows PowerShell. So it's no longer the way it used to be with Windows PowerShell. Whenever you would upgrade, you would be stuck with that version of PowerShell until you would uninstall the update. So it's possible to run multiple versions of PowerShell 6 side by side. You can run previews on the same system, and there's no it's a very low bar to get PowerShell running on your system. So if we take a look at performance in the changelog, I took a screenshot of it, but it's more fun to do it ourselves. So look for performance. You can see just in the changelog, we see 18 hits on performance. So we can see there's performance issues in WSMan, performance analysis. A big focus in PowerShell 6, aside from the compatibility, has also been improving performance on multiple fronts. So let's jump into some code and take a look at how we can determine which version of PowerShell we are running. So first I'll switch over here. Open up the demo. So let's run PS version table and take a look what we are working with. So we can see we're running on PowerShell Core 6.11. And if we compare this output to what we would see on Windows PowerShell box, the main difference is that there's an additional field for PS edition. If you're running it on Windows, it will have a different output, and we also get the platform and the OS variable. Because it's a little bit hard to determine exactly which OS you're running on based on this, there's a function available for that on GitHub, get environment information. This is not my function, by the way. I kind of forgot who wrote this one. I think Mark Kraus wrote the original one. Where is the... There we go. Load up the function. And let's execute this and see which function we are running. So we run get environment information. You can see we're not running on Linux, we're not running on Windows. We are running PowerShell Core, and we are running this on macOS. So why would we want to know this information? When we're writing PowerShell code or PowerShell modules, it can be important to know what kind of operating system you're running on, because of certain external tools that might or might not be available on the system. For example, if you would call ping.exe on a Mac, like I'll do that here, ping.exe is obviously not found, but if we just type ping and we get ourselves, then we'll just get a working command. So by determining which operating system you're running on, you can build in compatibility in your PowerShell code and in your PowerShell modules. In most cases, you don't have to put in exceptions, but in some cases, some DLLs or the .NET, the full .NET DLLs are not available in PowerShell Core. Then it's important to know that you're running on a non-Windows OS, so you won't have to try to still load those DLLs. Cool. Yep, the number of commandlets. So if you go over here, and we run get command to get an idea how many commands we have available, pipe that to measure. We can see the number of commandlets we have available on a Mac is by default significantly lower as what we're used to on a Windows 10 box. Because on Windows 10, I think without installing anything, we'll have about 3,000 commandlets available. So that's a bit of a difference. All right, moving over to the Azure PowerShell module. So last September, just before Microsoft Ignite, they released version 0.01, and currently we already have a production version 1.3.0. It's backwards compatible with the Azure RM module. So if you're familiar with Azure RM, this used to be the collection of PowerShell modules, but these were not compatible with PowerShell Core, so they've rewritten the entire Azure PowerShell module to AZ. So if we want to take a look at this module, we can connect to the PowerShell gallery. We do find module AZ, and let's hope my Wi-Fi is fast enough to actually find this. There we go. And if we now pipe this to install module, we'll have the module installed by the time we get back to this. And it's also backwards compatible with Azure RM. So what this means is that there is a command available, enable Azure RM alias. And by running this command, it will actually create the Azure RM aliases. So if you have existing scripts or automation modules, they can still use the Azure RM aliases. They've switched over with most development to the AZ module, but the Azure RM module is still supported until 2020. So even though the main part of the development effort will go into the AZ module, you won't have to switch over yet. So to get a bit of work done with the AZ module, we'll switch over to this demo. And in case you're not familiar with the new Microsoft Docs, so here we have create. So if we actually want to try to run a command, for example, connect AZ account, we now have a new button called try it. And if we hit this one, I can sign in with my account. And I should already be signed in. And we'll go for PowerShell. I'm not logged in on this system. Okay, there goes that demo. Let's. So what I'm doing right now, I should have tested this before. I'll connect to my Azure Cloud Shell, and why is it not working? And I'll try to use my credentials so I can actually connect to it. And yeah, that's the wrong one. There we go. My apologies for that. It should be working now.
Hey, no worries. I think most of us know how difficult it is credentials with Azure these days, man. It's tough.
Yeah, it's surprising. Let's see. I have no idea why it's doing this. Maybe do secret Azure.com. Yeah, sure. All right, so we should be good to go now. If it still doesn't work, then there we go. Excellent. So if all else fails, we always have incognito mode. Cool. So the demo I want to show is we can go over here, and right from the documentation page, we get a try it button. And once we select our correct Azure directory, it will connect to Azure Cloud Shell. And in Azure Cloud Shell, I'll be able to run this code. So all I have to do is tap copy, paste it in here, and we can get connected to my Azure account. Well, obviously, I don't have to authenticate because I just already authenticated. So let's get on to the next step. Cancel this one. If it wants to do that. And what I'll do instead is I'll kill my Cloud Shell and run the next command. So what we can see is we can just go to the documentation, and we can see a command like new AZ resource group, and we're going to create a resource group in East US. Wait for the Cloud Shell to be back up, and we'll be able to run these commands directly in our Azure environment without having to have a separate shell over straight from our browser. So it's a easy way to get started, and to also directly try out what you read in the documentation. And we can see we're authenticated. So I'll just copy paste it in there again. And now I can directly run this command. I've already run this command before, so I will definitely want to update it. So the next one is I want a username and password for my VM. Hide this one. Nope. Username is Jaap and my password is super secret. And we can go through this entire tutorial, but I'm not going to bore you with that. But as you can see, we can just go to this to the documentation, and we get a shell on this side. And now, if we take a look at PowerShell version table, we can see we're running the latest version of PowerShell Core, the latest stable version, and it's actually running on Linux. So if you're playing around in the documentation, you get a Cloud Shell that's running on Linux. For any of you who've worked with Cloud Shell before, in the past it used to be a combination of a Linux container and a Windows container. And the Windows container was only used to run Windows PowerShell. But now that PowerShell Core has been out, they've completely switched over to PowerShell Core on Linux. Cool. So what have we done? We created a resource group. I've fixed some problems with authentication to Azure, which is never easy, and we could run commands directly in Cloud Shell. So next up is if you're ever going to be working with Cloud Shell outside of the documentation, this is going to be something you see come back quite often, because Cloud Shell, if it's been idle, it says 20 minutes, but I've also have seen it trigger with less than 20 minutes. And if you would click reconnect, it would be quite similar to pressing the refresh button that I pressed before. That allows us to reconnect. So what is Cloud Shell? So Cloud Shell is an app in Azure. What it does is there's a Cloud Shell client. And in a nutshell, what it does is it connects your browser session to one of the already running Docker containers in which Azure Cloud Shell image is running. And the moment you say you want to connect to it, it will connect your profile, which is what we can see here, authenticating to Azure and building your Azure drive. It will connect all your settings, your entire configuration of your Azure Cloud Shell every time you connect to it. So it's a good way to have a central shell that's completely configured with the tools that you want to have. And also there's a very big selection of tools available in there. So since pricing is always important, the nice thing about Cloud Shell is it's almost free. There's no upfront cost. You don't have to cancel it if you're not using it anymore. It says pay only for what you need, and the only thing you need for Cloud Shell is storage. So the first time you connect to your Cloud Shell, it will ask you to create a storage account, and by default there's an image in there of I think it's 3 or 5 gigabytes, which contains your specific settings. So there's a lot of languages on here. This picture is already out of date, as you can see, because currently it says they're at PowerShell 6.1.2. So I should probably update this one. And we can see we have a number of other languages as well, because we might be a PowerShell user group, but there's Python, Node.js, Go, .NET Core is actually also at 2.1 right now. Other than that, there's a whole bunch of tools available. So all the all the Linux tools you would expect to be there are already pre-installed. There's tools to manage databases, to do configuration management, and there's even full-fledged code editors in there. And obviously, source control Git is also available. So this is one of the things I use my Azure Cloud Shell for. Whenever I'm on the go and I want to I can just log into Cloud Shell. All my keys are configured there, so I can quickly do commit somewhere or make any changes I need to make. And I think I'm going to update later. There's also something called CloudDrive in Cloud Shell. So a CloudDrive is a persistent place to store your data. And the nice thing about the CloudDrive is it's just it's also mountable from Windows. So anything you store in your CloudDrive, you can also access it as a network drive. So it's a very easy way to copy files in and out of your CloudDrive. So you can either keep your tools up to date or whatever you produce or want to feed into Cloud Shell, you can do that using CloudDrive. So let's jump into working with Cloud Shell. Here we see our Cloud Shell already timed out, and I don't think it has been 20 minutes, but I'm not sure if anyone timed me. I think I did it about 10 minutes ago. So what we can see here, it's requesting a Cloud Shell, and usually it doesn't take more than 5 minutes. So first thing we see, we have the PowerShell button here, but we can also switch over to Bash. The moment we switch over, it will actually request a new Cloud Shell. The nice thing is that when you're in Bash, you can still call PowerShell. So PowerShell is available when you're on Bash. And there's a number of other buttons available here. We can change the font size. Okay, it's already large. We can upload and download files, but uploading and downloading files using the browser is not that cool. So let's see. For example, I have the PowerShell preview available, downloaded here. This is a Windows version, so it won't do much good in Cloud Shell, but just to show how easy it is to share files with Cloud Shell, if I just drag and drop this in here. Wait a second. You can see it loading. Probably should have picked a slightly smaller file. You can see we're currently in the Azure drive. If you do get PS drive, you can see we have multiple drives available. So instead, I'll go to home. I'm in my profile right now. You can see the upload destination is in home. So if I type dir, you can now see this 60 megabyte file. With a simple drag and drop, we can get this into Cloud Shell. So if you want to take a look at the output we get if we would run the get environment function again, we can copy this, switch back over, and we can right click, paste. And run get environment information. And we can see we get a lot of information back. And you can see we are core, we're running on Linux, we're running on Ubuntu. Not sure why it gives so much more information right now, but probably because we're running on Linux. So let's clear this one again. Nice thing about Cloud Shell is that we have a lot of commands available. So if you remember that I had the terminal open before. When I took a look at the number of commands available here, we can see we only have 400 by default. If we take a look in CloudShell, we'll see there's a lot more commands available here. So that's 5,000, and that's because of all the modules that are already pre-installed here. So we already and a number of other PowerShell modules available. So that's the reason there's a lot more here. Also the SQL Server module. Cool. Let's see, what else did I have for CloudShell? Copy move files. Yes. Yeah, the Azure scoping part. That's the cool part. So before we were in the Azure drive. So if we switch over to that one, if we do get child item, you can see my subscription key, subscription ID. And if I type Visual Studio, we have tab completion. You can get into my subscription. If I go to resource groups and I do dir instead of get child item, you can now see that. Let's see, what was the tutorial resources group that resource group that I created before is actually available. And this is actually quite cool. What's happening here is we can just browse to our Azure subscription as if this is an actual drive. So if I would go into PowerShell Conference Asia, for example, you can see the path updates and everything I type in here. When I type dir, I can get the information here. But also, if I would decide to create a new AZ VM, name world. Yep. You can now see it doesn't prompt for anything else but just my name, and it's actually oh, that's good. I'll cancel out this one. But what was actually happening here is that it actually is creating the Azure VM or any kind of resource I would create. It actually creates it in the context we are executing it in. So the fact that we are now in this specific resource group, so PSConf Asia in this case, means that it will actually be executed in that scope. And the way it does that is by checking the current path and supplying that as a default variable. That's what I have for Azure PowerShell. I think this one will take a little bit too much time. We'll go to the takeaways. So the takeaways of PowerShell Core, we have it available as an optional download. As part of the development effort from the Azure team, they've completely refactored their Azure module to be renamed to AZ module. It's not just Microsoft that has been doing this. For example, VMware, they've completely refactored their module as well. It also works on PowerShell Core now. My company, Rubrik, we also updated our PowerShell module to be completely PowerShell Core compatible. There's now a rapid release cycle, so PowerShell Core is being released approximately every 6 months and also has a shorter support cycle, similar to what you've seen with Windows 10. There is a module called the Windows compatibility module. I could not show you that one because I'm running this one on a Mac. What this module does is that all the commandlets that are not available on PowerShell Core, and then you can think of commandlets like what's a good example? For example, the PKI module, so the one that allows you to create certificates on your system. It uses a lot of full .NET DLLs, so that doesn't work on PowerShell Core. But by using implicit remoting, so just by executing the commands in a PowerShell 5 context, so similar to running invoke command and specifying a session type, and the session type would be a PowerShell Windows PowerShell session. Do the command and then get the output back in PowerShell 6. So it's completely transparent from a user point of view. If you have the Windows compatibility module enabled, then you can run your Windows PowerShell commands in PowerShell Core. And obviously it's available on all platforms, so it's a fantastic development, because I can now use my MacBook whenever it doesn't crash to run my PowerShell code. That leaves us with questions. Are there any questions, either from the feed or from the audience?
Polling the audience now. Anybody questions? Yeah, I don't think we have any questions. That was a really great, really thorough presentation.
Okay, well, either I did really good or I did really bad if there's no questions. Can you see if there's any questions on YouTube?
I don't see any in the comments.
Okay. Excellent.
Maybe one question? Yeah, what's up, man? I'm going to restate the question.
Okay, perfect.
Yeah. Right. So the question is, with especially with PowerShell 6, how it's so similar to CloudShell now. What would be the use case for using CloudShell as opposed to using a local shell environment? Since you have, your local JSON, you probably have your local development environment, all nice and set up and clean. So what's the use case for using CloudShell over a local shell?
So CloudShell has the benefit that you can run it from everywhere and still have access to all your tools exactly the way you have them configured. So if you're walking around the office, someone asks you, can you quickly do this? You have access to your environment the way you configured it with all your RSA keys and everything you need. So the moment you jump on someone's computer, you log into Azure, you can access that. I think the main use case for me, aside from writing or testing short bits of PowerShell code, is just managing Azure, because unless you explicitly configure it, it doesn't have access to your local resources. So for most scenarios in which you would manage your servers on premises, then I would use a regular shell over CloudShell.
We can probably see you better.
Yep, absolutely.
Did you have a follow-up?
That's.
So the question is, you mentioned that you can have CloudShell configured so that it's the same on all of the machines. What kinds of things are you configuring that you want to be the same on all of the machines that way?
I'm sorry. Is my screen share disabled now?
It's disabled now. We can see you.
Okay.
Thanks.
Perfect. No problem. what I meant with configuring CloudShell was actually just connecting it as a network drive to your system. I might have explained it incorrectly. So by default, whenever you connect to CloudShell, your cloud drive is always connected. And because your cloud drive is just an Azure storage account, you can mount it as a file share to your local system.
So you can do things like put SSH keys in there and some configuration JSON and that kind of stuff in there?
Yeah, that's correct. You can put your PowerShell profile in there, and everything will load in there.
Great. Well, I guess one question I had was you mentioned, demoed a little bit using the Azure Drive provider so that you can change directory into a resource group and create a virtual machine there. Is that something that you can replicate locally, or is that only in CloudShell?
You can replicate it, but it is specific behavior to CloudShell. So the way you would replicate it in a local system, it is possible, but I don't have any example of that.
Right.
I can. I think if you talk towards the laptop, I can hear you. Otherwise, the audio will drop.
Yeah, that was one of the things that was explained to me as one of the advantages to CloudShell. You can just kind of move around in there and create stuff in default places like that, whereas that was really hard to do with a local session.
Yeah, if you do a local session, then you always have to provide like the resource group and the exact location where you want to have it. And if you can browse it like it's a file system, it makes it easier to understand. And like for example, if it already disconnected, but right now I'm in this folder. If I do get AZ, oh wait, it's no longer shared. So if I'm if I'm in my root folder, if I just browse into my subscription and I type get AZ VM, then I'll get all my Azure VMs in my entire subscription. But if I'm in a resource group or in a specific folder, then I only get the stuff in there. So it also executes a lot quicker by doing that. So that's a nice benefit.
Awesome. Did we have any more questions locally? Yeah, so the question is, you demonstrated in the Azure Cloud Shell a quick little simple command to create one VM in a resource group, but that's really not how you do that at scale, pretty obviously. So the question is, what's your approach to the way you would normally in an automated fashion, build up your environments, in your normal CI/CD kind of process?
In my normal process, I would either use ARM templates or I would use something like Terraform to deploy my environments. There's also a number of PowerShell modules available that simplify lab building, and they provide you with templates, and you can just say, okay, just push out these templates so many times and do that.
So you'd say that thing that you demonstrated, creating that one-off machine, the normal use case for that would just be kind of ad hoc. I want a machine to mess around with, kind of thing.
Yeah, exactly. And the example is more that it is aware of where it's creating it instead of having to explicitly specify where it's created.
Right.
I also saw a question in the chat though from David. David, I'm not sure if you're still around. I can actually not use YouTube chat because I don't have a channel. So you asked if I could explain what thread job is, if it's something like parallel streams or pipelines in the classic coding languages. So thread job, if you're familiar with PowerShell jobs, so PowerShell jobs is just a start job. Thread job is a lightweight version of this, because if you run start job, it takes like a couple of seconds for the job to start up, and if you have to wait to receive the job, it takes a bit of time, and it's a fair bit of overhead. So if you have a big process that's going to be long running, for example, you want to query a whole bunch of data to fill up your CMDB or something, and that's going to be running for like 30 seconds to 5 minutes, something like that, then PowerShell jobs are just fine. But if you want to parallelize something that's a bit more lightweight, then the only other option we used to have before PowerShell Core was to build our own run spaces, and then you would have to work with the .NET run spaces, and you'd have to build and configure this yourself. There was also a PowerShell module for this that simplified this. And now in PowerShell Core, they've integrated run spaces, so the lightweight version of PowerShell jobs in a start thread job. So you'll still have to write the logic yourself. I'm not sure which classic coding languages you mean in particular. I hope this answers your question. I know there's a bit of delay, so I'll wait for David to respond.
I think we've got one more locally too. Yeah, so what's your next favorite language after PowerShell?
I actually quite like Python, and I've been getting started with Go, but Go is still a bit weird for me. It's completely different, and Python is quite close to what I'm used to with PowerShell. The syntax is a bit hard. I think the first time I wrote a Python script, I wrote it in VI, because that was the only editor we had available. And it took me half a day to write a 20-line script just to find out where I made typos, because there was no what do you call that, syntax correction, and I had to run the script every time to see if I made any errors. Good learning experience, not a fun learning experience.
Yeah. Right. I think we got one more. Do you have a sense of what you might try to do with Python?
What I do with Python, I actually, to be honest, I haven't touched Python that often in the past 6 months. I've very much been focused on work on our PowerShell module. What I've used it for is writing deployment scripts to deploy Linux hosts on which the choice was either Python or Bash. So then the obvious choice was Python.
Right. Nobody wants to do Bash.
Nope. It's nice that we can run Bash on Windows nowadays, though. It's a cool addition.
More questions? All right, so I think we'll call that a Q&A session. I just want to say thanks again for coming and staying up so late to present to us. We appreciate that. Yeah, thanks a lot. I think we'll go ahead and cut you loose and let you get some sleep, man.
Okay, excellent. Thank you very much. You guys have a nice evening and enjoy all the pizza and the cold beverages.
All right, thanks a lot, man. We'll talk to you later.
Thanks. Bye-bye.